Hello, this is an interview with the authors of the paper on memory-assisted prompt editing to improve GPT-3 after deployment. If you haven't seen it, I've made a comprehensive paper review on this paper, and I released that yesterday. So the authors that I'm having on today as guests have seen that paper, and we're able to dive right in. So if you haven't seen it, it might be a good place to check it out. I wish that you have a lot of fun following this interview, or that you learn something, or that you're entertained. Ideally, all three together. And yeah, have fun. Bye-bye. Hi everyone. Today I'm here with Aman Madaan and Niket Tandon of the paper Memory-Assisted Prompt Editing to Improve GPT-3 After Deployment. Aman and Niket, thank you very much for being here. Welcome.
Thank you for inviting us.
So you've set out to write this paper, and I guess the viewers have probably seen the review. And this is really cool because these large language models, sure, we now have a fine-tuning endpoint at GPT-3, so it is a little bit possible to adjust it to your use case. But I think what you're doing right here comes the closest to what people imagine when they hear AI. Like when I go to someone and sell them an artificially, like an AI system, they imagine a computer program that learns immediately, right? That they can like tell things to, and it adapts, it gets smarter as they interact with it. And largely the AI community has not delivered on that promise. We train things on static data sets and then we deploy them and they're frozen. Yet your system, I think, it comes the closest to really to live up to that promise. So I think that's really cool. How did you go, like, how did this come to be? How did you figure, let's build something, let's build a plugin for GPT-3?
Our original motivation was, can we personalize very large models such as GPT-3? Rather than having many copies of a giant GPT-3 model trained in one place on one static data, along the way with the user, the models can improve, personalize over time. This was the original motivation why we started with this work. And GPT-3 was a great example to start with because it is such a large model that at the time of writing, it was not possible to fine-tune these models.
Yeah. So I think similar to that, one of the reasons why we specifically thought of having a plugin of sort for GPT-3 is, so I was using Copilot for some time. And Copilot makes this same mistake every time I write a print statement. So I'm using something like Python 3.7, which has f strings, which is a way of displaying the output, which you can nicely splice strings with variables. But the Copilot would always use the older version of print statements. And I would have to go back, edit it, and make it the f string that I want. So it was natural to, there was this urge, I wish there was something that could personalize this ID to me, or this instance of codex to me. And, something like a hash map would work in that case. So whenever GPT-3 completes it with an older print statement, I can just have a regex that replaces it with an f-string. And that kind of motivated this whole idea of having a small plugin outside of GPT-3 that stores these error cases and can correct them on the fly. And in the first version, we had some sort of proof of concept with kind of mix of those kind of data. But the idea is to kind of not having to train the model and having something super light that can adjust to these things that not people repeatedly.
Yeah, it's cool. And you don't even need to be OpenAI to do this, right? Because most research sort of assumes you're in control of the model, but this is really something you can just hang in front of whatever model that you're consuming, which is pretty cool. So I think it is important to say that I was quite critical of the paper in some places, and is good to inform the viewers that there is actually a V2 out that addresses, I think, almost all of these criticisms in one batch. So I just quickly want to show that. And you told me that it got done like just in time last night or so. So there is a new version of the paper, which is on GitHub right now. I guess that's also coming on archive in the in the near future, and that does have a lot more experiments, because I think one of the issues I had is that you said, well, we just want to present the framework of things, and you did some experiments, but can you maybe just talk about what new experiments you've added and how those turned out in this new version? Because if with new experiments and being state of the art, it sort of invalidates my point of, well, you just present only a framework.
Yeah. So we did add like two different themes of tasks. One is ethical reasoning, and the other is more word reasoning. In ethical reasoning, this is a recent topic on ethical AI, which is, as an example, if I have turn on the blender at 3 a.m., I ask a system, is this ethically correct to do or not? And the system should probably say that it is not okay to turn on your blender at 3 a.m. because it might disturb your neighbors. That's one theme, which is ethical AI. And we have two different tasks within that. In one case, the input is, a string, like I said, turn on the blender at 3 a.m. like a situation. And the output is whether it is good, bad, or not, and like with some clarification or some understanding. Sorry, not clarification, just understanding of the model, why it believes this is the case. And we have two different types of understanding in it. That makes up the two different tasks. One is the model presents its understanding based on an explanation of the sort that it's not good to wake up your neighbors or disturb your neighbors in the night. That's one. And the other setup we have, which makes up a different task, is it says this is about care or harm. This is about the topic what this situation is intended to bring out. So that's one task, one theme of task. The other one is more word reasoning task. So we add on to the synthetic lexical relation task that we had in the V1 paper, and we add on to word scrambling and other tasks which are involving anagrams and how to correct a word misspelled and so on. So those are like two different themes of tasks we have. Aman, do you want to say something on the second task?
So I think we also added one other task, which is factual question answering. So suppose that user wants to ask factual questions like who is or where was a certain person born, or where did they go to school, so things like that. So in those cases, there is no understanding that the model can display of the instruction other than the answer itself. So for example, if you ask where did Albert Einstein go to school, if the model says Stanford, then you can correct the model and say no, it was ET at Zurich or something like that. And then you can store these corrections in the memory again, and then when you create the prompt, you would bring in some examples which are similar to the question on which the model has been wrong before to make the prompt. So for example, if the question comes in, where did Winston Churchill go to school, then you would already have an example in memory of the Albert Einstein example, and that we show is helping the model in getting better at these tasks. So two different things, ethical AI and factual questions. So those are that.
Have you so this it's pretty cool, and I've had a flick through this paper that the tasks seem to be much more extensive. No, that's not it. It's so you had the ethical one. You give a few examples right here. On the right, we can see, for example, the understanding. This question is about loving your partner. This question about seeking medical attention if you feel there's something wrong, which is a lot. I think the gap to what people usually call common sense gets smaller and smaller. Have you let any actual users use this system with GPT-3? So you came up with your own data set, as if I understand correctly, your own sort of feedbacks, sometimes heuristics and so on. Did you ever just, set this in front of someone and say, here you go, try it out?
No, we have not. That's one of the things we would like to do. So we have not done that yet. And in fact, in just to clarify, the the data sets that we have here are the feedbacks on ethical reasoning, for example, is not something that we came up with. This was present in the data itself. So this was a data which was crowdsourced through Mechanical Turk, and there were actual users who or actual Mechanical Turkers who gave this feedback. But on the other hand, we have not tried this on any real users. This is the closest we came to reality in some sense. But we would like to do this in the future.
Yeah.
Yeah.
It'd be super cool to see how real people interact with this. Sorry, Aman.
Yeah, so I think so. Like Niket said, that for both these data sets, the data set is real. So you're right. In the first version, we had one of the data sets that we collected ourselves, but in this case, the feedback is given by humans. So in some sense, we are approximating that process by a linear data collection process as opposed to a bunch of workers working on it at the same time. But yes, it would be great to kind of see if once deployed, if this actually does better on one of these tasks or one of the new tasks that we discussed.
I'm going to guess that specifically for GPT-3, the restriction of OpenAI on what you can build with it and the approval process would prevent you from actually releasing this, let's say, to the public as a service. But one could think of maybe using another model or just, your code is online, so people could use it with their own API key if they really wanted to.
Yeah, that is correct. And in fact, just outside of this paper also, we had been working on T5 model with a very similar architecture, T511B. And so that's one of the models we could, release in the future.
Is there a difference between smaller models and larger models in how much this type of feedback is needed? Like, you specifically work with GPT-3, and I get it, that's the model that we cannot train, but is it also more necessary to provide feedback? Can you tell us a little bit about the differences between small and large models or different models?
Let me just start with that. So it's a really good question, first of all. So our general experience with injecting, some knowledge, external knowledge, like, common sense knowledge into models has been, as the model capacity keeps increasing, it requires comparatively less knowledge injection. So smaller models like, let's say BART base would benefit a lot by, we have seen this in the experiments in the past on and others have also reported it. If you inject external common sense knowledge, then those models get much bigger boost than, for example, T511B. Bigger models get less boost. So we have tried the same, very similar architecture, actually almost the same architecture. There's a paper under review on T511B. And what we also observed there is that there is substantial gains with T511B. The only difference in mechanism is that, there we were able to have a fine-tuned T5 model, which understands the task a lot better than in GPT-3, where there was not even an opportunity to do that. So probably because of that reason, we are seeing bigger boost in GPT-3 than we did with T511B. But in both the cases, there is substantial boost in performance by doing so.
Cool. And have you tried, so what you are doing right here, it goes very much into the direction of correcting the model if it, let's say, makes a mistake or if it misunderstands something. I had the sort of the opinion that personalization, very much in the sense of how you, Aman, said this before, I want my IDE to do something in a particular way, would benefit hugely from that. Is this something on your mind too? Are you looking into various like personalization aspects of these models? Is this something that is for some reason not possible?
I think that's a very good point. And in fact, in the first version, in in this version, we have some experiments in the appendix, also in the earlier version, where we simulate users who sort of interact with the model in Hindi or Punjabi. And that's some sort of personalization. It's kind of a language personalization. So there's a person who's speaking in a dialect of Hindi or Punjabi, and there's a certain phrase they use repeatedly. And if you can store that in memory, then sure, the first time the model is not going to get it, but the next time someone comes and uses the same word, hopefully it'll be patched. So we did some experiments on that angle, and we also have examples in the ethical AI setting where the model was able to correct or work with slang usage. When people were saying the same thing in slangs, right? So one person comes and they give feedback. I think it's a very promising direction for personalization, and I anticipate that in the near future systems that do it successfully would use a similar architecture where they have this memory that kind of has a trap to the query.
If we get into the paper a little bit, like into a bit more sort of the technical aspects here, I want to jump over to the experiment section. And you had an interesting plot where you show, not this one. This one is one of them. An interesting, no, this is the out of vocabulary. I think the main ones are, I missed them. Oh, here. I've drawn so much over them that it's it's a mess. Specifically, I was wondering this PFB of 0.5. Did I interpret this correctly? That this means that you only get the feedback half of the time? Does that mean the user can only give feedback half of the time, or the model only receives sort of this feedback, or the model only gets to go through this feedback loop half of the time?
The user gives feedback half the time.
Okay,
so essentially
because then
the memory grows slowly.
Then it makes total sense that they end up sort of converging to the same place, because I was wondering, if your procedure was only active half the time, it should fail half the time. But if the user is able to give feedback half the time, it would still learn slowly, but it would still learn over time. Okay, that's...
Exactly.
We wanted to simulate reluctant users who might, not always give feedback. So sometimes you want to give feedback, sometimes not.
Yeah. Have you thought about pairing this with recommender systems? Because in recommender system, sort of a recommender system would group me together with other users who have like similar preferences as I do. So, conceivably I could say, well, maybe I'm able to sort of profit off of feedback of those users, right? If I give some feedback and I'm very similar to these users, it might be the same. Is this something that could be done, or...
I think this is a really neat idea. We did not think about it, but now that I think about it when you mentioned it, I think it makes total sense to have a community of similar users all having, similar preferences. It makes total sense, and I think it will be very cool to try this in the future.
Well, maybe. Or you always know who the feedback comes from. It's like, your dumb friend entered. I'm thinking of these people who like altogether enter dumb things into Google so that Google autocomplete suggests the dumb thing.
That brings to a very good point about sabotaging our system. It is possible. I mean, if you keep giving it really bad feedback, eventually it is going to apply bad feedback to newer examples, and this is a valid point, a valid concern. We also don't know if our memory can be consistent over time, or it can start deteriorating and becoming like inconsistent among itself. I could just give different examples with different feedbacks. So there is not our work, but there has been other work on how to maintain consistency in a memory over time. But that's an additional direction of research which we can employ within our system to keep it healthy and consistent.
Are there in another point in the paper you mention these different pieces of the puzzle in this framework you propose. You've added more tasks. Have you also thought about amending or augmenting some of these things to be more, let's say, more complicated? Maybe replace some stuff with learned things. So far you have the lookup, which is a language model or an embedding model. Yet the other pieces of the puzzle here are fairly simple so far in your experiments. Are there any obvious next steps where to make this more powerful in any of these 4 parts?
Yeah, so that is true. In fact, the current implementation is for the combiner is as simple as, it's just a threshold. It's just thresholding over the inner product. It's that simple. But eventually, we are in the process. So this is very much work in progress, where we are trying to, beef up the other components also. Right now, our only focus was on lookup and memory, and the other components are very simple. But eventually, this is where we are getting at. Work in progress. And I think there are lots of details where, our current system is very primitive in the sense that it only assumes that the users are, really nice, and that they don't give you bad feedback. That's one. It also assumes that the users can, you can effectively retrieve from the past, and that's not always the case. There are cases where we are not able to do that. That's why we had to set, a higher threshold where we only get good matches and like good feedback, which are very similar. But something which we would like to do in lookup, I'm just giving an example, is like, suppose your input is turn on the blender at 3 a.m. and now a new input comes in which is saying playing drums late night. Both of them are in the analogy space of errors. They're actually very similar, but that's not something which our current system can match. It can at most say, oh well, if I find something like turn on the mixer at 2 a.m., that's similar to something I've found, and it'll pick that feedback. So this kind of really recursive reminding to a model based on similar error space is the next step where we are getting to with this lookup.
I think also in the space of the combiner and the prompter specifically, there's probably a lot of potential to still be gained. Yeah. I mean, instead of concatenating, you could imagine many smart ways of combining what you retrieve from the memory with what you already have. Potentially, you could even ask the model itself to come up with sort of like a better prompt, or to sort of, so you can maybe abuse the model again to suggest better things to you. I mean, I think that the possibilities are quite open here to make this very, very cool and very powerful. Another thing that I wasn't sure about is your baseline, this grow prompt baseline right here. And I think I tried to explain this a little bit. Do I understand correctly that the grow prompt baseline, you take whatever the contents of your memory are and you just append them to the prompt before the question?
That is correct.
Okay. My concern was a little bit that it's not exactly right, that the baseline, because the prompt is structured differently, but I don't know how important that ultimately will be. Probably not.
So I think we do structure the prompt in the same fashion. So we get examples, and the structure of the prompt does not change. It's just like a longer prompt. So in the video, you show an example prompt, which is in the appendix. It's the same format. It's just much longer. It's basically as much as we can fit.
Yeah. So wait, we can look at one here.
Yeah, there you go.
So this is the entire prompt, which I found pretty cool, that not only do you prime the model to sort of give you the answers and give you the understanding, which is, I think that's a pretty cool idea in itself, to get side information with your main information out of these models that you can then use to query them again. I think the applications for this are much larger than just this one. You also train the model to specifically view or regard or pay attention to the clarifications. my question was that this is a bit fat. When in your main method, when you retrieve a clarification, do I see this correctly that you append it at the end right here to the question currently, and this grow, sort of this baseline, would append something like here in between? Or do I see this incorrectly?
Right. So in the grow prompt, what we do is we essentially add more examples to the prompt. So instead of retrieving something from the memory, it's added to the prompt itself.
Yeah.
Yeah.
Okay.
So that's
cool.
Yeah.
Then I've understood correctly.
The mechanism is kind of very similar to our own method, sort of like retrieve the right feedback in some sense. The only thing is we are allowing GPT-3 to attend over those. To attend over it, rather than we providing a retrieval function from the memory. We hope that GPT-3 will be able to attend over it itself.
Yes, I mean, yeah, and if it fits into the prompt, it's pretty certain that at least it might pick up on it, right? And you make good points here. You say that this grow prompt, it is quite a bit larger and it cannot scale up. So as soon as things fall out of your memory without a good retrieval function, you're essentially limited to a very short time horizon. There is this experiment here, this plot right here, which I haven't touched at all, which it goes a little bit into out of vocabulary domain, a little bit into the domain of different languages, maybe lower resource languages. Do you want to comment a little bit on what you did there and what your findings were?
Yeah, so the idea is essentially very similar to what I was talking about earlier. So the prompt itself has examples from Hindi, for example, and then the questions also come in Hindi. And for the first time round when the question comes, GPT-3 would not know because it's primarily English. Funny thing is, for Hindi, actually, sometimes it gets it because apparently there's lots of English corpus online. But for Punjabi, it struggles. So the idea is the user comes in, enters something, the model doesn't get it, it goes in the memory. Next time someone comes, has a similar question, so the model retrieves understanding from the memory and hopefully is able to do the task.
So to clarify that the questions are in Punjabi, for example, that you would like to have answered, and you also construct a prompt in Punjabi, or is the prompt still in English?
The prompt is transcribed in English, but the question parts are all in Punjabi. So the script is not the Punjabi scripts. It's still English, but parts of it are in Punjabi. So we have an example in the appendix. Yeah.
Oh, yeah, that's a good point. we should go.
It's
yeah. No, this.
Yeah. So I think one of those.
This is the end right here. I think this one might be.
Yeah. So those are in Hindi, and the one in the bottom is in Punjabi. So the person is trying to the scenario I had in mind was someone's trying to learn English and they're trying to look up words. So in the first case they are saying what is the opposite of edit. So they ask it in Punjabi. So they know that they want meaning of this word edit, and the rest of it they ask in Punjabi, and the model says something that the opposite of this is something else, and then the person can say no, I want synonym or something. And there's like one missing piece here, which is that you have to tell the user antonym means opposite in Punjabi, so they know what the model is is trying to say. But
so you could interact with this thing sort of across languages, and you could prime it to say which parts do I want in which language, because it would obviously not know, I guess, what you want the answer in.
Yeah, you can definitely add language tags, and that could definitely work.
I mean, it's a pretty cool example of personalization, right? Because you can imagine you personalize this exactly to sort of how you want to interact with it, and someone else who might be more or less skilled at English or in reverse in Punjabi might do a different thing. That's pretty cool.
Yeah. There's one more point I wanted to touch here, which you kind of mentioned earlier with respect to the prompt. So, as you noticed, in our prompt, the model does not only give out the answer, it also gives out its understanding of the question. And I think that's a very kind of crucial piece in this design, because one of the bottlenecks for us earlier was a system that assumes that the user knows the real answer is not really practical, because if a user knew the answer, why would they be playing with the model, right? Outside of a annotation setting. So this kind of breaks that barrier. So you might not know what the answer is, but you know for sure what you asked for. So you can always tell the model, no, this is not what, I don't know if you're right, but I know for sure this is not what I wanted. And that kind of helps in improving the performance. The performance of the model itself might be whatever it is, but we are helping the model in understanding the intent more precisely. That's the main trick here, so to say.
Yeah, I like this getting the answer with the understanding. I think that's pretty powerful. Not only to interact with the model, but also just to understand what it does instead of just getting a simple answer. Could be a good recipe for other applications as well. Did you have to fiddle around a lot with sort of the prompt structure or the structure of what to add? Right now you have a bar and then clarification and then colon. Is this the first try and it worked, or is this the result of many hours of sweat and tears?
No, so it's first try, and we did not, and it was intentional because our goal was not to show a lot of games. Our goal was to see if it works. And this weird hash and new line, this is what we took from OpenAI's website. They had a bunch of instructions on best practices for formatting your prompt. I think they have changed it since, but we just took it from OpenAI's website.
Yeah, and this was also one of the main motivations, like, even if I don't know how to exactly have the prompts here, let me, there are two ways in which you could gain improvements here. One is in the in-context examples within the prompt, and the other is at the question side. There are like just two aspects to for fiddling with this. And there's been a lot of work on, how to give the right in-context examples, what order, what examples, how to select them. Our focus is on the question part, like, only on the input part, which comes from the user. And we are trying to pull all the knobs, like turn all the knobs at that end. And in some sense, we were able to overcome, some limitations which our prompts probably have. Like maybe there are much better ways of coming up with a prompt than we have. But I think all those methods are just, if we plug in any of the nicer methods to, come up with a better prompt, that's just icing on the cake for us.
Could you, if this was first try and it's still in there, so obviously it worked, was there things that didn't work out over the course of this research? Like things where you got stuck, or maybe even ideas that you had to discard halfway through?
I can tell one which really bothered us for a long time. It's on contrastive prompting, which is we wanted to also give like negative answers. Like, can the user just say, no, that's not the right answer, with the autoregressive models, it is really difficult to somehow give them steer away from probability mass towards certain tokens. Like it's really difficult to do that. We are still not able to effectively do that. Like ideally, in the real world, users will give feedback of the kind, instead of clarifications. In addition to clarification, they can also say, no, this is not right, or this is why it's not right. Like the model came up with, what is the capital of India? And it says the capital is Mumbai. And I just want to say, no, it is not. It is like Delhi, or like you're looking at the wrong places. And that's something which we were not able to do. And I think it's an open problem, like this kind of negative prompting. It's valuable from a feedback perspective for the future. We just don't know how to solve it right now.
What is your, you played obviously a little bit with these large models, with the API, presumably also tried out yourself a lot of things, I can only assume, over the course of this research. Is there anything maybe also a bit independent of the research itself. Is there anything that you came across that surprised you about these large models and how people can interact with them?
I think for me, one of the things that actually stood out from early days is how good Copilot was. And I think if you really have been using it on a day-to-day basis, and I have been using it for a few months now, it has consistently gotten better. And initially, it had these small weird quirks. So these models can basically generate left to right or top to bottom. So if I have but when you program, you would write some functions below, and then you go back up to a function, and you want to reference a function below. So that did not work earlier. So it would only condition on things that it had seen so far in the file. But they have improved over that stuff also. So I think it's astonishing that at least in the structure setting, how good they are for generating things. At the same time, it's also interesting that even when you have 175 billion parameters, how poor the model is at common sense, because it's very clear when you go from these structured settings to a more open-ended setting like common sense generation or common sense reasoning. I still think the models struggle a lot, so it still is clear that there's a long way to go. So there's a bit of both. So I think you have to choose your end application wisely. But there are clearly very cool applications that can be built, for which you don't need AGI, so to say, as long as you have a very good pattern matcher.
One of the surprises for me was on just the fact that these models are correctable. A model can make mistakes which are hopeless. It's just total understanding is wrong. But I think over time what has happened is with larger models, even though there might be many claims that it is missing common sense and it is these models are dumb and so on, but I do believe that for a certain question, yes, there might be cases where it's not coming up with the right answer, but they're still correctable. They are not dumb anymore. I think these models are getting they are correctable in the sense that their output is not completely off, and with some guidance they can get to the right answer.
Awesome. Is there something other than that you feel I have maybe not touched in my review that you would like viewers to know, or be able to understand, or anything that I've maybe gotten wrong?
Yeah, I think most of the stuff you said was correct. Like nothing was wrong really. Your understanding in almost everything was correct. Just the only thing was,
I'm not fishing for compliments. I'm legitimately, if there's something that you feel like people should know about this that we haven't talked about at all,
Yeah, I think the part about that you mentioned in your video about the feedback could be misleading. I think we briefly touched upon it, but I think that's a valid criticism that still holds, and that was one of the things that we have not been able to solve even now. So we are trying different kinds of retrieval, conditioning on the expected output, doing something like you said more complex in one of those four modules. But I think that remains a valid criticism of the work, that there would be cases where a feedback would distract. So the model was going to say the right thing, but now because you have this thing, it's saying the wrong thing. But we think that problem is kind of, there's an easy way to solve it. It's to show both the answers to the user and let the user pick one. So, you show this is the answer that I would have given you. This is what I would give you with some retrieve feedback, pick one. But if you don't want to do that, then it's kind of very challenging, because the model somehow has to know that it's going to make a mistake, and only then it should pull a feedback, etc. And those are kind of having it's very hard for models to know that they are wrong or to know what they don't know. So that's a big challenge, and kind of one interesting research direction that we are pursuing outside of this, which is how can we let a model know that they don't know, or they have started going wrong, and what can we do in those cases?
I agree. And if you can do that with a model that you don't even have access to. I think that would be a little bit of a grail of research. Like that would be seriously cool. And I think it would improve a lot of applications of these models around, all around technology. Cool. Well, Niket and Aman, thank you very much for being here. It was a pleasure, and I hope this work goes on and becomes more powerful over time.
Thanks, Yannick. Thank you so much for having us.